Hello everybody, so today we'll talk about the system design of Facebook Live comments. And this is take 2, so I will do some deep dives. So today I will talk about these two topics. Number 1, scalability, and number 2, this is a kind of follow-up question. How can I handle client disconnections and ensure viewers don't miss comments? Okay, so I will talk about this. Okay, so I will start from the scalability. So I put this number here as the non-functional requirement. So I will do the backup envelope estimation first. So I will do it here. So I will talk about this from 3 perspectives. So number 1, throughput. And number 2, spike of throughput. And number 3, storage size. Okay, so for throughput, so basically, okay, so let me firstly quickly review the current system design here. So I will quickly go. So when user opens a new video, live video, that user makes request to this fetch real-time comment API. So this is SSE endpoint. So when user opens the video, it makes a request to this fetch real-time comment API, and the SSE connection is created between the client and comment service here. This happens for user 1 and also for user 2. And currently I assumed that there is only one comment service server, physical server. And that being said, so let's say this user 1 is watching the video 1 and user 2 is watching the video 1. Yeah, the same video. In that case, when user makes a comment, this comment service firstly receives the comment with this time HTTP request, notes the SSE, and first thing it does is persist the data in the comment table. And then this comment service has to send this message to user 2 because they are watching the same video. So what I can do is it internally has the mapping from video ID to SSE connections, like user 1's SSE connection, user 2's SSE connection, object. Yeah, so because this comment service has the mapping in memory, so from this video ID 1, this server knows the SSE connection of user 2. So this can send the this can send the comment from user 1 to user 2 through SSE connection. So this is how the real-time, comment currently works. Yeah. So as I said, I have 2 endpoints for real-time live comments. Number 1, this post comment API, and number 2, SSE connection, fetch real-time comments API. Okay, so for throughput, where was it talking? So 1 million concurrent users. Okay, I will talk about 2 things. So number of comments and number of connections, SSE connections. So for number of comments, okay, yeah, it says 1000 plus comment per sec, but this is each video. So let's say there are 1K videos. Yeah. So with this, the number of comments created is 1 million comment per sec. So this is a new comment throughput. And number of concurrent user is 1 million times 1K is 1 billion concurrent viewers. And this is quite much. So many. Okay, so firstly, the API post comment, or just the make comment API, this is 1 million comments per sec. So when I take a look at this comment service, okay, so this user one makes request, and for API gateway, this is fine because it internally scales out. API gateway is a cluster of servers internally, so it can scale out. And then this comment service, this experiences 1 million comments per sec. Yeah, typically, one server can store up to 1 million SAC connection, but it is the case for the very well-tuned high-spec server. But of course, I'm pretty sure I will use such high-quality server here because there are so many users. So that's the kind of, upper limit. But I also calculate the upper limit from the memory size. So typically, SSD connection uses 10 kilobyte of memory. So let's say the memory size is 500 gigabyte. So, and each connection is 10K. In that case, I divide it and I get, this becomes million. Oh wait, this becomes million. The million is gigabyte, so this much. So yeah, 50K connections on a single server. So which means that $1 million divided by 50K. Wait, what are we talking about? Oh, sorry. I'm now talking about the concurrent viewers, not the throughput. Okay. So let me firstly talk about the concurrent, WebSocket connections. So there should be 1 billion concurrent viewers, and each server can store 50K connections. Is this correct? Let me check. 50 gigabyte. No, I think this is. Ten kilobytes. So this makes it 1 million. The 1 megabyte. Yeah. So this becomes this make it gigabyte, and we have 500. So this many. Okay, so I think this is correct. This is so many. So obviously what I can say is, so the memory doesn't become the problem. So the only, the problem is probably the CPU. Yeah. So, and as I said, I will assume that this server connect 1 million, connections. So I can say 1 billion divided by 1 million. Yeah, per server. So in this way, I get 1K servers. So we need 1K servers here. So this is so many. Yeah, but obviously maybe I overestimated this but we assume these numbers that 1,000 concurrent video and each video has 1 million concurrent users. So this big number is understandable. Okay, so and we need so what happens here is there are 1K servers, and which means that 1 million comments per sec are sent to 1K servers. So it makes it 1K requests per sec of write request. Yeah. So, okay. I have two things I'd like to discuss from here. So firstly, I will continue the discussion about the throughput of make comment API. So there are 1K servers, and each server experiences 1K requests per sec. So for EC2 perspective, this is fine because typically average EC2 instance handles around 1K requests per sec. So this is okay. But for the database layer, the throughput is 1 million requests per sec. So this part is still 1 million requests per sec. Yeah. So this is quite heavy because for PostgreSQL, typically each server can handle around 10K write per sec. So what I can do is use the sharding. So I can share the database with video ID because comments are basically sorted by the video. Inside of the video ID, and also obviously there are joint queries across video ID. So comments are separated and independent according to the video ID. So definitely I would use this video ID as a sharding key. Yeah. But handling, how many is it? So 1 million divided by 10K is 100. 100 servers, database servers is a kind of tough. So I would switch this comment DB to DynamoDB now. The great thing about DynamoDB is it internally does the sharding. So I can specify the partition key, which is just like the sharding key, and DynamoDB internally does the sharding by consistent hashing internally. So what I can do is I make this partition key, and instead of this index in B3, I use sort key here. Wait, what am I doing? Video key ID. Oh, no. So sort key should be comment ID because I want to sort by the comment timestamp. But one thing I have to take care is in DynamoDB, the combination of partition key and sort key must be unique. So I have to add the comment ID as the suffix because in the same video, comment timestamp may collide. Okay, so this is what I can do. And the good thing is DynamoDB internally does the sharding, as I said, consistent hashing. So what happens is internally DynamoDB decides the number of shards in a good way. So yeah, I don't have to think of the database sharding anymore. So that's why I like to go with DynamoDB. Okay. So now I'm pretty sure this write request can be handled. Yeah, because this 1 million requests per sec is divided kind of, shared it into multiple shards. Yeah. So I mean distributed to multiple shards. Yeah. So of course, when there's so many requests is coming, it should be so many, data inside of the DynamoDB, so I can expect that the partition number of partition is also so huge. So now I can expect that, request is distributed to multiple numbers of partitions. So I'm pretty sure this 1 million requests per sec is now can be handled. Maybe one more thing I'd like to mention here is DynamoDB does the partition automatically by, or I should say, tunes the number of partitions internally by storage size and also by the throughput. So if there's so many throughput to one partition, it internally split it to multiple servers. So yeah, that's a good thing about DynamoDB. Okay, so what should I say? Now I will talk about this part. So number 2, send the comments. But here, now comment service has 100,000 physical servers. So it can cause the issue. So let's say user 1 and user 2 are watching the same video ID 1, and user 1 is connected to the server number 1, and user 2 is connected to server number 2. In that case, in server 1, user 1's comment cannot be sent to user 2. We need a way to propagate the messages, comment, across multiple comment service servers. So that's something I have to think now. So for this, what I'm thinking is I'm using the Redis pub sub. So this comment service, once receives the comment, publishes it into this Redis pub sub. And this Redis pub sub, so I create the topic per video ID. So in this way, firstly, this comment service knows which topic it should send the message. And for each topic, now the servers, which has the SSA connection, which we have to send that video. If there is an SSA connection in memory, which expects that video ID. Oh, sorry, wait a minute, how should I say? So here, I will think for each SE connection, which video ID is needed. And let's say video ID 1 and 2 is needed for users which are connected to server 2. In that case, that server 2 has to subscribe topic for video ID 1 and video ID 2. And in case of Redis pub sub, this is a push type. So the server subscribes the topic, and after, the registration, subscription is registered. Now Redis pub sub sends the message to all the subscriber servers. So this is push model. Yeah, and I have two things I'd like to talk about this Redis pub sub. So number one, this is fire and forget. So once the message is sent, this Redis pub sub doesn't store the message anymore. And also if the server is not available and if the message is not sent, it doesn't retry. Redis pub sub doesn't retry the pushing. But in our case, this is totally fine because we're developing the live comment service. So user has to see the comment, live comment. He doesn't have to see the past comment, basically. So it's totally fine with fire and forget. And of course, if the user has to see the past videos, because data is already stored in the DynamoDB, it can bulk fetch the comment, past comment. Yeah, so that's something like the client can do. Yeah. So I mean, this fire and forget Redis pub sub is totally fine. And one more thing, so the reason why I use Redis pub sub and not Kafka is because Redis pub sub is in memory, so it wicked first. But Kafka is obviously it persists the message in the storage, yeah, abandoned file. So it has some more, latency here, and in a case the real time, I mean, the non-function requirement comment propagation is less than 200 millisecond, which is quite strict. So that's why I also use Redis pub sub over Kafka here. Yeah, the durability of Kafka is not needed, as I said, because users, with this Redis pub sub, we just have to send the real-time message. We don't have to take care of the past message for this portion. Yeah. Okay, so that's something I can do. And now, so there should be how many topics here? Because we have 1K videos, there are 1K topics. So number of topics is fine. And there are 1K servers, so each server is sent from up to 1,000 servers. No, sorry, Redis pub sub. Oh wait, what am I doing? Okay, so one thing. So here, even though we have Redis pub sub 1K topics, this topic is a kind of logical namespace. So physically, if there is only one Redis pub sub, the connection between this Redis pub sub and the common service physical server is only one, no matter how many topics this common service server is subscribing. But because we have 1 million comments per sec, which means that this part becomes 1 million comments per sec. So this is quite heavy, Yeah. Typically, Redis can handle up to 100K requests per sec. So this is too heavy. So I have to think of the way. So because the throughput of the messages, comments is 1 million comments per sec. Yeah. So this is 1 million sec, and also Redis pub sub has to send up to 1,000 servers destination for each 1 million messages per sec. And typically for Redis, it can handle 100K messages per sec. Yeah. So that's something I have to take care. I just mentioned that for this Redis and comment service publish path, the TCP connection is kept alive, so it doesn't have to send messages again and again. Yeah. So, okay. That being said, The single Redis pops up instance is not enough. So what I can do is do the sharding here. And Redis, I use the Redis PubSub Redis cluster. Yeah. So with Redis cluster, what happens is it internally does the sharding by the message key. Yeah. So this is completely fine. The message key can be the video ID. So according to the video ID, this Redis cluster pops up is sharded. Yeah. And the number of cluster, that's something I have to discuss. I think obviously it can be 1 million divided by 100K. So I have 10 instances here. Okay, here. So that's something I can do on this Redis cluster PubSub. Okay. So now this is 100K requests per sec times 10. And this one for each, this should be 1K requests per sec. So I introduced Redis cluster PubSub here. So this is fine now. Yeah. So each comment service is connected to 10 servers and up to 10 Redis instances. And for that connection, up to 100K messages to send. Yeah. Good. Okay. Yeah, this time I assume this 100K requests per sec is fine, but if it seems like it doesn't work in the production, of course we can increment the number of, increase the number of instances in the Redis cluster. The good thing is we don't have to do the resharding of the data with this Redis PubSub because data is not persisted in this Redis cluster PubSub. Okay. So now I will talk about the spike rater. So firstly, I'd like to talk about the storage size. Oh, and also I also have to think about this bulk comment service, bulk fetch API, scalability. Yeah. So in the middle of the real-time video request, while the real-time video streaming, basically this bulk fetch comment API is not needed. Yeah, as long as there are some users who enters the video space and started scrolling up. Yeah, but in anyway, this bulk fetch comment API is stateless. So I can just, for this tower layer, I can do the scaling out. Yeah, horizontal scaling, maybe with like AWS auto scaling. Yeah, according to the memory or CPU usage. And for this bulk fetch, because we put the partition key and sort key in a good way, so basically the query is internally distributed to multiple partitions, shards in DynamoDB. So the server load is distributed. But one more thing I can do here is probably put the Redis, and I would make it the how should I say, read through cache. Yeah. So probably what I can do is, because according to the user, the range of the time to be fetched by request differs. Yeah, according to the time user opens the video first. So what I can do is kind of for each key, I make it in a, let's say, 100 millisecond to 200 millisecond key, and I, kind of store the message list of messages. Yeah. So in this way, let's say users try to get the messages between 150 to 250 millisecond. It has to fetch these two keys and merge them together, and also drop the messages which are out of the requested time window. So I use a kind of granularity of the timestamp. I mean, I kind of, create a window, par window, messages cache here. And I will probably do the same thing with CDN. Yeah, so with CDN, the messages are cached physically close to each client. So yeah, this also speeds up. Yeah. And also decreases the load to bulk command service, and especially DynamoDB. So that's something I can do. Okay, so I talked about the throughput. So now storage size. So only concern is the comments. So there are 1 million comments per sec. And let's assume each comment is 100 byte. So in this case, it becomes 100 gigabyte per sec, right? 100 billion. This is kilo million, so mega. No, this is 100 megabyte per sec. Yeah. Okay. Oh, no. So, because we use the DynamoDB, it internally, I can think that this infinity scales. So, the thing I have to consider and take care is the storage size per partition. So in our case, let's assume there's so much data in DynamoDB and throughput is high. In that case, the partition is created per video ID. So I calculate the per video storage size. I will think of that here. So this is per video. So in each, every second, 100 kilobyte of data is created per video. And in an hour, let's assume that the video is 1 hour. In that case, or I should say, because each DynamoDB can store 10 gigabyte of data for each partition. So I calculate this and calculate the number of seconds, or I should say the time, maximum time where the messages can be stored. So this is 10 to the 5 sec. And one day is around 10 to the 5. So this is 1 day. So if the video is 1 day long, all the comments cannot be stored in a single partition in DynamoDB, and it becomes a problem. But obviously, one video is less than 1 day. Yeah, and also, yeah, I kind of overestimated 1K plus comment per sec, so I can say, yeah, storage-wise, DynamoDB completely works. Okay. Now I will talk about the spike of throughput. So one thing I can say is, even though, I use these numbers, I already did the discussion with all the videos, across all the videos. So even if there is a spike for a specific video, and let's say it becomes 10 times or 100 times, it doesn't make all the concurrent users or all the comment to be 100 times. So even if, I can say, because I assumed 1K concurrent write videos, even if one of them becomes 100 times, it becomes only 1.1 times. Yeah. So throughput-wise and storage-wise, spike can be handled. But only one thing I have to take care is the hot shard. So here in Redis cluster Redis PubSub, I use the video ID as the partition key, or I should say salt key. So if there are so many messages coming to the specific video ID, then that Redis cluster experience heavy load. And same thing can be said for DynamoDB. If there is one video which has so many comments, only that partition becomes a problem. I can say this is hot partition. Yeah, completely the same way as Redis cluster. Yeah, so I'd like to quickly talk about those. So for Redis cluster, so what I can do is, okay, so I will think of this from the from the product perspective. Typically, the spike occurs only for the, very famous, and also I can say, already planned videos. So let's say there is a World Cup match or maybe concert of the very famous musician like Taylor Swift. In that case, it's already planned and scheduled. So what I can do is, if there is a video which should be quite high spike, I can completely separate this Redis cluster PubSub layer as the dedicated to that video ID only. So in that way, the kind of idea is I can do the subshard inside of the video ID. So it doesn't affect this existing more general Redis cluster, but I can do the sharding internally for that video ID. I can say this is subsharding in a sense. So in that way, I can handle the spike on this Redis cluster PubSub. For comment DB, this is a kind of problem. So I think what I can do is, instead, I will use the PubSub. So before talking about that, I'd like to mention one thing which helps the scaling discussion. So in case of the Facebook Live comment, even if the user makes, let's say, 1 million comments per sec for a specific video, those cannot be displayed to the users. Because if we do that, in the user's app, 1 million comments scroll down in a sec. So user cannot see, not at all. User cannot read all of them, obviously. So I can say up to maybe 10 or maybe 20, 30 message per sec is the maximum. We don't need any more data for that. So I think what I can do is, instead of talking about kind of, subsharding or subpartitioning discussion in DynamoDB, I will firstly introduce the sampling here. So, of course, here, this is one thing I will do, and another thing is here, do sampling. So, of course, we have to store the messages to the DynamoDB. Yeah. But so what I can do is, okay, and so I can say we don't have to store this DynamoDB data immediately. For this real-time propagation, this must be really quick. But for this data storing, it's used for bulk fetch. I mean later, not the real-time messages. So what I can do is introducing the kind of Kafka here. Yeah, and because with this Kafka, this command service just have to publish the messages to Kafka, and it doesn't have to wait for database query, so it doesn't heavy overload the DynamoDB layer. Yeah, and obviously Kafka has much better throughput than DynamoDB, right? Yeah. So of course, yeah, we can create multiple topics here, and internally I can do the partition, specify the partition key, and scale out internally in topic. Yeah. So of course it can be partition should be maybe video ID, but probably anything is fine. Yeah. We don't have to guarantee the order inside of the partition in this case. Probably. Yeah, maybe strictly saying we should, and we should. Okay, sorry. So I can do partition key is video ID. Yeah. Okay, so I will go back to the main discussion. So command service now pushes the messages to Kafka, and then do the sampling, then push the messages after sampling to Redis cluster pops up. So now this Redis cluster pops up is not heavy loaded too much, and all the messages are stored in the DynamoDB. Both of them are satisfied. Okay. Yeah. So that's something I can do here. Oh, and of course here, there are multiple consumers, one consumer per one partition key, and also they can do the bulk write to DynamoDB. It doesn't have to save the message, save the comment one by one. So in that way, we can, increase the throughput for DynamoDB writes. Yeah. Okay. Okay, so I've finished talking about this scalability. So now, finally, I will talk about this. How do we handle client disconnections and ensure viewers don't miss comments? So, yeah, the thing is, I can rephrase this. What happens if some component is broken or user's connection is dead? So when user's connection, SSC connection is dead, the client should just make the request to this SSC connection API, fetch real-time comment API. So with that, SSC connection is created to command service again. So now it can get the real-time messages again. Yeah. So that's something I can do. Because users are watching the right videos, probably we don't have to, fetch the bulk videos in that case. Yeah, but probably this is this is definitely the product decision. So if we'd like to backfill the missing messages, the client should call bulk, bulk fetch comment API. Okay. So in that way, client can just reconnect and get the live comment again. Okay, so yeah, I think I've talked both of them. So that being said, I finished my today's system design practice. Thank you so much. Bye.